In the next minutes, I will share our StorPool experience in how to design and build Tier 1 infrastructure. Our intention to this talk is after the end to open a discussion and to share experience with other people, thoughts, examples, use cases, so on. So first, let me clarify what we mean by Tier 1 infrastructure, because in some context it might refer to the best option, but in the other context it might be not the worst. In this talk, Tier 1 infrastructure means the best one. Infrastructure that can serve high-performance applications with low latency requirements, works reliably, predictable and without interruption, and be easy to scalable. So, the best infrastructure. Few words about StorPool, just to see from what experience we are talking. We have been on the market for a long time, so it means that what we do is not completely wrong. We have assisted more than 400 organizations to build their clouds for their projects. These clouds are for customers from different areas. See, and service providers, enterprise, so on. The idea here is that the projects in which we have participated are not just for one case. They cover different use cases, different requirements. Currently, there are more than 300 active deployments with StorPool. The number here is lower than the number of organizations just because some of the projects naturally didn't survive by mostly economics changes. But that is the business life. And we are open to share what we know, and any feedback is welcome. Such a user groups are a perfect place for such exchange of experience, of knowledge. So we are inviting for sharing and feedback. So now on topic, design and build. We believe that everything starts with the understanding of the customer's needs and goals for their current and upcoming project. Because when we know these requirements and goals, we can propose them a tailored solution for that particular use case. You know, such thing as one thing solves everything. There does not exist. There is a universal solution of the universe. So, based on our experience, we have collected the top 5 cloud users' demands. And let's list them with an explanation what they mean in the terms of Tier 1 infrastructure. Uptime. The demand is about everything to just work no matter what happens. Hardware failures, power outages, software errors, human errors, name it. In terms of infrastructure, uptime does not refer the time since last boot. It means time during that infrastructure is able to serve its workloads without interruption, no matter what happens inside. Performance, of course, performance. But what performance means in terms of Tier 1 infrastructure? It is not about million IOPS, gigabytes throughput, petaflops. Yes, these numbers are important because they indicate what we could squeeze of our hardware. But usually, cloud users need consistent and predictable application performance. They want to know that how the way the things work today the same way they will work tomorrow, after month, after year. So that is the meaning of performance in this term. Which term introduces the next one? Scalability, often underestimated. Even if you design the perfect cloud infrastructure today, during the time, demands of your users will change, we will grow, we will shift. So you need to know, you need to be able to scale your infrastructure by their demands. And this includes scale up, just to replace hardware with, inside the boxes with better CPU, more RAM. Scale out, just to join another additional servers to your infrastructure. But also scale only what you need. Just a sec. If you need only more storage, just add additional storage devices or storage only server, or just replace devices with the bigger one. Need more computing, okay, add just compute nodes or upgrade compute resources. Or if you need both, join additional hyperconverged servers. Hyperconverged servers that participate as a compute and as a storage servers simultaneously, all the hardware inside. But the scale, the demand of the scaling is to scale only what you need. If you need more storage, scale storage. If you need more compute, scale compute. There is no need to, if you say, let's say that you need 20% more storage, but because the solution that you use, you are forced to buy the next big black box with the same capacity as the previous one, just because this is the smaller model of your vendor. It's not good. Even the ability to scale down is factor here. Time to time, things happen. We need to shrink our infrastructure to power off part of it, to save power, or to repurpose the hardware for different projects. This is also important. Disaster recovery. Sometimes very, very bad thing happens. Fires, earthquakes, floods, wars, whatever. Events that, as a human being, we cannot just handle or prevent them. So if you need to create the most reliable cloud infrastructure, then even the whole data center should be treated as a single point of failure. Yes, it is costly. You need to buy additional hardware, to mount it and rent additional place, all corresponding spendings. But this is like insurance. Insurance that even something very unlikable happens, a whole data center is dead, your business still continue work. And if your data and if your time of recovery are more, how to say, valuable for you than the price of the hardware, okay. More. Next. And last but not least, cost savings. With unlimited budgets, everything is achievable. But what about when, and as usually, we are not in that luxury? Every IT business is pressured, from one hand, by ever-rising prices of the hardware and ever-rising operational expenses, salaries, rents, electricity. That's for one hand. And on the other hand, the constant demand of end users to lower their prices. So that's why cost saving is in this list. Their underestimation could be a project or even a whole business killer. So when you design your Tier 1 infrastructure, cost savings should be one key criteria. Okay, for those 12 minutes, that was short about the demands. Of course, each project has its unique specifics, and I would say we cannot describe everything so general. But in general, yeah, cannot be so general, but in general, this is the framework of the user demands, cloud user demands. And when we know them, let's start building. And again, everything starts with questions and conversations. What is the amount of storage space needed for the project? How potentially the project grows in the next 1, 3, 5 years? What is the plan? For what kind of infrastructure load, for what kind of infrastructure, come on, for what kind of computer load that infrastructure is built on. Virtual machines with WordPress, database servers, virtual machine streamings, video streamings, cryptocurrency miner. Different workloads have different characteristics, and how to say, we cannot just put some hardware. So, collect as much information as we can at this step will help us for the next, the hardware selection. Hardware is one of the things that can kill any project, both in its beginning and in its operation. And I'm not talking about only hardware failures. Every hardware has few prices, multiple. One, the price to buy it, and one, the price to operate it. Oh, come on. Every hardware uses electricity, which is pure expense. Modern hardware can provide you with same or better performance with less power consumption. So using outdated hardware, just because you have it, could be waste, not a gain. The hardware selection could be a topic for an entirely different talk. This is a very broad theme. I mentioned it here because this is an important part of the infrastructure creation or expansion. From now, let's say that we selected the suitable hardware for our infrastructure. So let's use it. Yay! I show a typical diagram of infrastructure that we recommend to our customers, and it works for 1,000 of projects. 2 switches with 2 physical links between them. The redundancy of the connection between them is using over these physical links, and use technology provided the switch vendor, OACP, MLAC, nothing hard here. 3 servers, or we recommend 5, because with 5 servers, even 2 of them goes down, the 3 other can take the workloads. And infrastructure will continue working. Each server is connected by 2 independent links to each switch. And over this physical connection, one dedicated V1 for the storage traffic, the green one for the other types of traffic, internet management, so on and so on. There could be more VLANs than these two, but for picture, for the image, I draw only two. And as you can see, nothing fancy here. No expensive and specialized hardware, no complex network designs, very simple topology. Yet, such a design offers a high level of availability. If one server goes down, other can take over its workload. If one switch goes down, the other one will do the work. Even such a cross-connection connectivity issues are not critical in such topology. Such architecture allows customers to use mixed configuration in their infrastructure. So this means that you can easily add one or more storage-only nodes to extend the storage. Same for the compute nodes, same for the hyperconverged nodes. And probably the sweetest option, the freedom to mix servers with different roles. Start with one type, after a few days, start from different types, and so on and so on. That helps to your flexibility in your infrastructure. Okay, that was about the hardware selection. Now I will continue with the software stack, because hardware without software is just an unusable thing to keep the door open. Fortunately, nowadays, there is a lot of software for every layer. And by layer, I mean operating system, network stack, virtualization, cloud management cloud management, storage. I'm sure that each one of you can name at least 2 solutions in these layers. I'm not trying to tell you what to buy. I just want to share our company's approach to software stack selection. Operating system. Our approach here is to choose widely used Linux distribution. Red Hat and derivatives, Debian, Ubuntu, SUSE. I was very surprised that this is pronounced as SUSE. Even I read here on Cyrillic to understand it. So, why them? Because they have a proven history of stability. Long life cycle. We can talk about the 5 to 10 years of support, patches, backports. Can be used for free, but also they offer paid support if this approach is suitable for your use case. And one very important thing by our opinion, their willingness as usage make there to be a lot of information in documentation in the internet about issues, how-tos, and so on. And always is better if someone has already hit some problem, found the solution, and you just apply it to your case, and not to be the first one who hit something. That was about virtualization, operation systems. Virtualization. I'll be very brief here. Everyone in this room know what I'm talking about, and I will not dig down because of that. But same as the operation systems. Well-known software pieces with a lot of features and capabilities that can handle a lot of use cases. Next software layer, the storage. Yes, I'm tempted to start talking about why StorPool is, but I leave this for later. Let's start from them. Do not underestimate the importance of the storage layer. Because, you know, if you lose your data, most probably you lose your business. As simple as that. So, in addition, more storage solutions on the market not only abstract the physical devices into a single storage pool, not only scales this storage pool, but also provide what should also be able to squeeze the maximum performance from the underlying hardware. Ensure redundancy and take care for data recovery. Efficiently stores the data, replication, erasure, coding, whatever other technology you use. Do instant snapshot with no performance impact, and even send these snapshots to a remote location, again, without performance impact. So the storage solution has an extremely important role in Tier 1 infrastructure. So all its capabilities could have a direct impact on our top 5 cloud users' demands that I mentioned earlier. So the good news here is that there is such solution on the market, and it is not only one. And I'm still priced to continue, so we'll jump to the next slide. The cloud management platform, the software solution that manages the whole infrastructure and enrich cloud operators with features that easy their daily job. Easy. Things like automation tasks, monitoring, templates, more and more. And of course, I will say CloudStack here. But I will say it not just because here we are on the CloudStack oriented event. No. CloudStack stands out as a major, mature and stable platform. It's been proven powering production clouds more than a decade, and offers a rich set of features like multi-hypervisor support, advanced networking, seamless integration with external systems. Not I'm the one who must list CloudStack features. My colleagues know them better. But also, CloudStack is known as its simplicity and operational predictability. And all of this, as well as many other capabilities and features, making CloudStack an excellent choice for service providers and enterprises. Yeah, and, oh man, as always, I'm in a hurry. As I said in the beginning, the intention of this session is discussion and experience exchange. I shared StorPool opinions, how to build Tier 1 infrastructure, and I know that briefly scratched them. But each subtopic could be a very broad, separate topic. And so now, any feedback is welcome. Thank you.